Hello everyone, my name is Steve. I want to welcome you to my YouTube channel where usually you can find Atari 800-bit computer and Commodore 64 computer content that is now available. Now usually I have been known to record things in Camtasia Studio, but there seems to be a problem with it recently that has been, well, I haven't been able to fix it. Basically after a certain amount of time, I don't know, like 20 minutes or so, it goes into static. The audio just goes all static and I can't figure out why, and eventually it returns, so I don't know what that is. If anybody knows, I appreciate some feedback because I spent many hours today, basically the whole day, trying to fix it without any avail. So anyways, I'm going to show you what people have been asking me for in this channel and do the best I can here. I'm going to explain how this assembly program works and how you can actually get your own stuff going. And eventually I'll provide these available for download at a website. I do have my own website, but right now, unfortunately, I have reached some kind of violation of terms with the host provider. I don't know what that is about, but I'll investigate that later. So what you're seeing here, obviously, is the turbo assembler, and I have a program loaded up here in WinVICE C64 emulator. The first thing you want to do is when you're starting an assembly program, we're not going to start from scratch since this program's already in here, we'll use this one, is you want to set what's called the program counter. This is the program counter. I have it set at a memory address, an area where memory is not going to be affected. And this 10,231 is being used, I believe, by the basic compiler, but I have no way to really show you the outputs of the screen. I usually like to be able to show like the book and go back and forth, but that's only when Camtasia was working, so kind of look that up yourself and you should be able to see that. Okay, so the next thing here you're looking at is these are labels basically that you set up in assembly, and I have one here for print because this is going to be used to print character, which are known as the AXI characters, to the screen. I can actually put that in here, I can put it down here, but it's the AXI characters. I don't know how to spell AXI now. The characters to the screen so that you can print like text listings and you can print numbers and stuff like that. Okay, the next part here you're looking at, these are defined labels I have for the horizontal position of the sprite. I put sprite X position, so that's what that is. And this is the horizontal position for the Y position for the sprite. Okay, the next thing here, these are actually being used for sprite number 2. This is obviously the horizontal position and this is the vertical position. I haven't defined them yet because I don't have them in this game for this demo. Okay, this one is called the sprite enable. So this is how you enable by using this register 53269. And this one here is a sprite pointer. We'll go over this a little bit later, but it basically points to where your frames are like to create in memory for each sprite. This one right here is the sprite color. This is the sprite enabled. I'm trying to grab what sticks to. Oh, multi-enabled. So this enables the multicolor for the sprites. And this one is sprite multicolor. You can kind of see they're kind of all listed here, but this is screen color. This will be the joystick right here. And these are actually high, this is the high byte, and then 252 it has to be the low byte for the character set. And 253 I believe is the place where I'm moving from the ROM character set into RAM. Okay, and the first thing we're going to do here is we're going to set up an instruction or an opcode called JSR, which is jump to subroutine, and this clear memory is basically clearing out the memory. Okay, I think that's for the sprites. I don't have to go back and look and figure out what that is later, but okay, the next one here, this is going to create the character set. I'll go over this a little bit later, but these are just basically kind of like doing a go sub in BASIC. It'll basically go sub to that line and return to it when it's done. Okay, the first thing we're going to do here is we're going to basically define our sprite on the screen so that you can actually see it, and that's actually being done right here. This is defining the sprite, which is going to be a frame of 62 characters in height, or not height, but 62 characters total, basically. The sprites are actually set at 24 by 21, but this one is just going to define the first sprite, and we're going to store him in this memory location, which is where it's going to point to this later, and I'll show you how that works here. This is these are the animation frames, by the way. So this would be basically frame 1. Frame 1, and then this would be the so on. You know, we kind of get the habit here. This is frame 2, and it goes on that way down until all the frames are completed for that individual sprite, which we only have one on the screen. I also have sprite number 2, which is a missile, but I don't have it programmed in this part of the demo here. So this would be obviously frame 1 for the missile. And then this obviously down here would be the frame 2 for the missile. These are actually the phasers here. These are the bullets, if you would. We could just say like frame 1 for player bullet, basically. And then this one down here would be the frame 2 for the player bullet. So, alright. And that's because one is going left and one is going right. These are not animations. These are just basically going to show the same bullet on the screen. If you've seen my original first assembly program I put out there on my channel, you'll see that. So, okay, so it's gonna go up here first. So it's gonna load the X register with 62. And if you look down here, this is absolute addressing. So it's basically gonna take this, and this is gonna contain a 62. And when you go down here, it's gonna decrement. So now 62 is gonna go all the way back up here. And this is going to decrement this down to 61. So this is going to basically read in all these characters until they get down to 0. That's just another way to read them in assembly. You can decrement them or you can increment them, but it's usually just to decrement them. It'll still figure out where they all belong, as long as you have the correct addressing set up. Okay, the next part of this is actually setting up the characters where the character set, is going to be defined at. And I use 8192. These are the locations where I'm defining them. And there's going to actually be, let's see, there's 1, 2, same thing here, except this one, notice I did increment. I didn't do decrement on this one. I could have done decrement, I just done increment. Just another style of doing it. And this is going to compare it once it's 8. If it's not 8, it's going to go back to this line and keep reading this again. And remember, this 8192 is going to read in all these locations, so each time this is going to 8192, 8193, 8194, until it gets all the locations for filling in the data. And this is going to read in all different parts of the character sets. And those who want to know, I can run the demo quickly and show you what I mean by the character set here. And you might not be able to see my mouse, but if you look at the character, I'll move the character closer just in case my mouse doesn't show up here. You see right here, where he's near this green place, and then there's like right there's a pipe there, and you just see all the characters defined. Those are the redefined characters on the Commodore 64. And the 6510 processor initializes those and changes them once you issue specific addressing calls. So, which I'll probably do that later, but that's basically how it works. So let me go back in to the Turbo Assembler. Okay. So that's what that's doing. It's initializing all the different characters. Now we're going to do what's called a regular initialization, which I call setups, screen, sprites, and everything. This is the color. You saw earlier I had that defined as 53280. And this will be 52281, which is the border, basically. Just for people who want to know, I'm just kind of writing this stuff in. So. This flag is being used to figure out if a character has reached a certain boundary, and I'll need to explain that when I get down to that line, so I'll go over that a little bit later. This right here is I think this is the multicolor enable. I have to look this up quickly here. I'm just looking at a book right now called Mapping this Commodore 64. It has all of the memory addressing stuff where you can look it up directly in case you've forgotten what a memory location is doing or something like that. So it's horizontal fine scrolling, so it can be used for fine scrolling, but it basically does a lot of different things. So this one is enabling multicolor text, so that, as I mentioned, it kind of turns on the multicolor here. Okay, and these right here, I believe this is multicolor number 1 and 2. Just double check. 53282 right here. So it says background color number 1. So I'm just going to write that in here real quick. So it's background color 1, And this obviously is background color too. Okay. So this is multicolor 1, and this is multicolor number 2. So if I change these, I can change the multicolors of my characters in the game. Okay. This one here enables the sprites. I showed you that one earlier, and we'll redefine it, but this is how you actually store it in the memory location. So it's basically like doing a poke. What is that? SPR. You have to look up and see what that is real quick here. I don't remember the number. I think it's let's see, it's SPREN. It's right there, 53. So it's like doing a poke 53269, comma whatever this one was, 247. So that's how you basically go like poke 53 to, let's say it was 69, comma 247. So whatever that memory location was. Don't have them defined here anywhere, so I can really see them. That's Sprite enable register. I think I got the wrong one here, but I'm just going to go jump back up here real quick. I'm going to make a copy of this top part for my own purposes, and I can kind of explain stuff when we come across it. So I don't have to go back here each time and look these up. So I'm just going to basically make a screenshot of this for myself. You won't see any of this, but since I'm running Fraps, basically, I'm going to copy this. Hopefully it doesn't crash on me. Okay, good. I have a copy here, which you're not going to see, but it's there. So now I can just go back down to where it was. Okay, so let me look at that SPR and make sure I got the right thing here. Yeah, it's 53269. Exactly what I chose here. So, okay, so this next one here is the sprite pointer. This right now is starting the sprite pointer at 33. This is basically defining, I guess I'll go over this a little bit later, but this is defining where the character graphic is going to start at. Which picture are we going to look at in the multicolor, in the sprite animation frame. And 33 is the first frame in the animation. Okay, this next one is location 53287, which is the sprite color. So this basically changes the color of the sprite here. I'm going to write that in here. This is the sprite color. Okay, so down here, we can color in this sprite, and this must be a multicolored part of the sprite. Let's see. Yeah, this goes into the multicolors and everything. Let's see, SPRC0. Oh, actually, this was 53288. This one is 53288, and this one is 53289. I'm just going to write that in here. People want to know. 53. Look at it again here. Trying to get my screenshot side by side, but it's like taking up the whole picture here. So SPRC0 is 53287. So this will be 53288, and this one is 53289. That's the memory locations where these are being defined from. Okay, now I have set up a special area here. Well, I'm sorry. Yeah, this is just basically going to position the sprite on the screen at character position, horizontal position 40. Remember, this is right here, 53. I'm going to write it right here, but it's 53248. And then this one obviously is the vertical position, or 53249, which is also known as the Y position. So, okay. So this one right here, I showed you this earlier, but this is the sprite enabled multicolor, so turned on a multicolor. This is just basically telling I want to start in room, because it's going to load the accumulator of room and store it in room, so now room will have a 1 in it, and so will this multicolor. This one right here is location 53281, which is the sprite multicolor. I'll write that over here again. Multicolor. And this is this will be one of the other multicolors in the sprite. So these were changed to sprite multicolors, because you can have up to, I believe it's 4 colors in a sprite. Alright, this is going to clear the screen. This is basically taking the axis character to the screen. If you want to see that in BASIC, I can show you that real quick to kind of emulate what that's doing, but it's basically another way of clearing the screen. So if you go to like Common Basic and you type in print, type in dark here, print CHR strings 147, that will clear the screen. And that's basically what that's doing, is it's executing that command in assembly. And this next one is just going to draw the first room, so that shows the players, the characters, and the character set, so you can see it on the screen in the room. This one's going to fill the bottom part. You saw here is walking on the floor. This draws the bottom floor. This right here I don't have defined yet, but this is going to basically check which room he's in later. And this is the joystick positions. This is how you define the left position. And this is the right, and so on. This is the down, and this is the up. Remember, this joy right here is actually the memory location that we defined earlier, which is 56 through 20. Alright, and this jump move is very important once you're going. Oh, I missed this part, I'm sorry. This right here is actually telling. Actually, you know what this part is missing in this? Let's see, branches equal shot. Let's see, this is up, this is down. This is supposed to have another thing in here. 111, I'm sorry, 111 is the fire button. So basically, when I implement the fire button, I don't have implemented in this program, but in my original game demo, when you press the fire button, it shoots those little arrows, or harpoons, if you would, out of the player in each direction that he's pointing. And down here, this is jump and move, so this just basically stays in the loop here. Otherwise, you'll jump back to basics. You need to stay in the loop when you're in assembly. Just like in basic, you need to, if you want to keep your basic program running, you have to go back using the go-to. So this is like doing a go-to in assembly. Alright, these are very important so that we don't cross what's called a 256 byte boundary. If you cross 256 bytes, keep in mind each character is made up so many different bytes. If you had to do a disassembly, this load accumulator would actually come out. This one is, trying to think here, I think it's 173, and whatever these 2 bytes, the high and the low byte from 197 make up for. So I can show you that real quick if you're curious. I'm going to use, as an example, I'm going to use this one. I'm going to use the joystick and the compare 123 to show you how that looks in assembly. And then maybe we'll do the branch equals left here just to kind of show you. Easiest way is go back to basic and kind of show you from here. So we got the accumulator with joystick. I'm not going to hit enter, I'm going to get an error here. And we got compare 123. And we got bridge equal, I think that one was right. Let me go back and look at it, I can't remember. I think it was right. No, it's left. Okay, I just want to be exact. So we'll go back to here and it'll be left. Okay, I don't lose all this stuff. I did. So it's left. At least I'm being accurate then. So branches equal, we'll go to left. And then somewhere down here in your program you're going to have obviously a left label, and you're going to have code that does whatever for that. It moves the player left basically. So what I wanted to show you is how this would be defined and the outputs would look. Trying to get enter to get this line to go down, but it's not going down. I guess you can't enter that way. So anyways, the first one here for the load accumulator joy would be 173. I think it's 10,28, but let me just kind of do some calculations on this real quick. You take the low byte, for people who want to know how to do the Boolean math, and then you add the other one, and then you multiply it by a 256. And I'm way off on that one. It's 56, 320. I got this one wrong. 53, 56, 320. I'm trying to figure out which memory location this one would be. Oops, I went too far there. 56, 3, oh, up close, I think it's 10. Oh, so this is it. It's going to be 0. It's 0, 220. So this will be 220. This will be 0, and then this is 220. You just saw how I calculated that. So basically that's how you define that. can erase it here so we don't have a little bit of room here. The next one is compare 123, or also known as 201 123. The next one, if I'm not mistaken, I think it's 240. It's either 240 or 208, but I always forget which one it is. And it's going to be jumping to wherever the left label is. So if the left label is like way down here, let's say you have a right down here, and then somewhere down here you have an up, somewhere down here you have a down, and then I think I just lost all my stuff up here, but basically if you're jumping down here, you're counting each of these bytes. So when you say branch is equal to something, it's going to count. I think it's 208. I'm making wrong. You're going to count down how many different bytes it's jumping. So it starts here, cups. This 1, 0, 1, 2, 3, 4, 5, 6. So if you wanted to go back there, you would just branch equals 6. But otherwise, you would start from here, 0, 1. You can just count them as they're going through. If you have another line in here, like a load accumulator with 53, 280 or whatever, this would make up some other different bytes too as well. I know I'm giving kind of an extended lesson now, but this load accumulator would be whatever, you know, whatever the bytes turn out to be. I don't know, I have to calculate them again, but you kind of get the idea. So you can't cross a 256 byte boundary or you'll get error messages. So what I do, and to prevent that, and the reason why I showed you this, is back here in the program. I just want to clear the screen here. I set up these individual labels here. So this one's going to move it up, and this one's going to move it down, so it doesn't end up crossing it with a branch equal. So if you're using a be equal and you're trying to go down to a label that's way down here somewhere, and you suddenly, after you count all these, they've hit 256 bytes, and you keep going, you're going to get an error message. So it's better just to set up little labels earlier and just jump to those. Make sure you don't stick them inside of here or they'll jump inside of your actual routine. So you need to stick them outside the routine that you're executing from. So, alright, so this one is just going to jump when I get later. This jumps and ends the program. I had one in here originally here where you was done with the program CSSDN here, and it would execute out the program. I think you pressed a key or something, I forget what it was, but okay, so. And this is just setting up for my flip to routine, which will be used down here later. Okay, so I know this is going to get a little confusing, but you have to kind of keep up with me here. Okay, so this part right here is going to tell which direction our player is facing in. And I use this as a flag to kind of indicate which flag is facing which way to make that player face in that direction. So bit 1 right here, he's going to go do this routine that says check F2, which is down here. And if you look down here, it's inside of X2 here, it's going to be comparing the X and figure out where the X1 is, which is the movement of the player. And if it's at a 1, then we're going to flip 2. And this right here is really important because this is how I do that flip animation from side to side. Okay, so I don't want to kind of lose you here, but this is storing in the location of the player. This is just basically position the player on the screen so that we can see him as we're moving the joystick, because remember, I didn't explain it, I know I skipped over it, but this is the left routine, so if we're moving left, this is moving the player over against the far left, which would be the wall on the left there. Okay, so this right here is pausing the game, slowing it down. This jumps into the loop down here, because we want to, the reason why we're jumping down here is because if we haven't hit this instruction, if we're not at 1, then we're just going to jump over this part. Otherwise, remember, this up here is going to jump to this anyway. So we want to jump over the part if we're not ready to check that flag yet. So I just get that little, I saw this trick where you just kind of jump over it, basically. Okay, so it would skip all this in between. It would go down, right down here. Okay, and we're saying basically if the X is not a 1, we're going to increment the pointer. It's called pointer 2. What this is basically do is, if you see over here, it's incrementing through each animation frame. And then what they do is they store these frames right here where it says SPRPT. You might not remember earlier, but this was the, I'm just going to write it in here real quick. This was location 2040, which is for the animation. So that's how you get the animation frame. Remember, it started at 33, so if we increment it, it'll be at 34, so it's going to be pointing into the next animation frame. So each time you're incrementing it, it's going to the next frame of the animation. That's kind of how it works. Okay, so this one right here is checking to make sure we haven't exceeded 42 frames of animation, so we can flip it back to 33 basically when it's done. And this one right here is decrementing x1 because we're moving the player this way, which is decrementing to the left. So I'm going to run that program again. I'll show you, compile it and show you what I mean, what this routine's doing. It can be very hard to explain without Camtasia, but I'll do the best I can here. Okay, so right now the player's running. I'm going to put him over here, but okay, he's running this way, so he's running to the left. So when he hits this wall here, he's going to flip over here automatically, and I'll show you where that flip routine is in a minute. But remember, as he's running, he's at memory location 53,248. This is 53,249. So hopefully that helps you. So once he gets over here, he's at position 40, because remember he starts at 40, and if he's less than 40, he flips over here. What you'll need to understand later, though, is when he's running over here, he'll hit a certain boundary here at 255, and if he hits that, and you don't set a certain bit in the computer, which is location 53264, he'll automatically flip back over. Instead of going all the way over here, like he's going all the way over past this point, he won't. He'll flip all the way back over here, so it basically won't look correctly. It'll look like he's running halfway across the screen and flipping back over here real quick. So that's why you have to set that 53264 to 1 later, which is known as the most significant bit, and then it just basically continues the location 53248, sets it back to 0, and allows him to continue on until he hits like the next location. I basically just tracked where the X is again, so remember, once he hits that 255, so 53248, he's running, he's at 40, he's at 50, 60, 70, or wherever he's at. Once he hits 255 here on this line, we set 53264, and then it allows 53248, it flips it back to 0. So now he's going to run and he's going to be at 0 at this position. So 0, 10, 20, 30, or whatever. By the time he hits over here like 40 something, he flips to the other side. So let me show you that in the code. Okay, so right here, actually, let me see. I think it was up here. I showed you earlier. Right here, this is saying that he's at one position. So basically, this is saying, oh, sorry, I'm sorry. This is at 32. So he's at 32. I showed you the wrong one, but that's where he's over against left wall. So let's go over to the right routine. I don't mean to jump ahead, but I wanted to show you what I was just talking about when he's running over to the right. So this basically puts him in the face direction. This is the flag to check where he's currently standing at. Here's what I was talking about. Once he hits 255 or greater, that's what this means. Branch carry set is greater or equal to 255. It goes to the position, or the label called flip, which is down here. And it checks the flag to kind of see where it's at, so we can kind of figure out what we need to do with the player at that point. The point here is we set 0, we x1 back to 0, which is that movement, because every time he's moving, it's x1 moving, it's decrementing, and it's incrementing that way. So this sets what I was telling you, the most significant bit, to 1. So now he can stay in this position instead of flipping all the way back over here, and allows him to continue on where he left off at that point. And then you basically this is where I keep track of the flag, which is going to be checked up here, to figure out which what's the most significant bit set or not. So if I go up here, I'll basically say was MSB set or not, and that's location 53264. So that's what that's tracking up here. It's just basically tracking to see where what we're doing with 53264. So we're setting it to 1 or we're not setting it to 1. Okay. And this right here is a routine I used. I think this is checking another position where he's running at or something. Let's see, running CK1. That's what that stands for, running CK1. I'm trying to see where that's at. I think it's way down here somewhere. I have it down here, right here. It's right here. So basically, this is checking the flag here. See if it's at a 1, then he's going to go to this location here. And this is where it checks once he's past that new position. So he's now the most significant bit is set. He's moving still. As he hit 83 position, if he has, then we need to reset him all the way to the opposite side of the screen here. That's basically what this code is doing down here. It's saying he's at 83, branch is equal. Then we need to go down here, and we need to go ahead and take control of that. by moving the player back into his rightful place, basically. And somewhere down in here I had to check it and flip him back and eventually store in his location so he gets it put back in the right spot, basically. I don't know where it's at. It's down here somewhere. Right here I see a store. That's the up. But hopefully you get the idea. That's what's really important, is make sure you understand most significant bits, how they work, to get your sprite running completely across the screen so that it looks natural. Because I want to go back up where it was at here. So right there, then we're going to load the flag with 0, because remember now we're flipping him all the way back over here. So this is flag 0, and once he's that most significant bit, that's flag 1. That's how we're tracking where the flag's at. And of course we always want to set the MSB back to 0, so I'll just write that in here again for those who want to know. This is the MSB, or most significant byte. And this sets the X1 to 32, which puts him all the way over here. I think this should be 40, but I have it at 32 here. And this stores the location 53,248, which is his horizontal position, so that basically moves the player where he needs to go. And this jumps back to the loop and keeps it going again. That's basically how this works. The up routine is kind of, I'm skipping over some of this other stuff because this is basically keeping track of rooms and stuff like that. This isn't really necessary in the game unless you have a lot of rooms, and we only have one currently in the room, so we're not going to go over that right now. And also because I'm usually limited to times on Fraps, so I'm trying to rush through this. Okay, so this is the up position. This is checking to see where the Y one's at. If he's at 170, then we want to keep him at 170. And if you noticed earlier, I'll run the program again to show you, when he moves up, he doesn't move completely up to the top of the screen. He stops because he's hitting the bottom of the floor right here. So this is the bottom of the floor right here. We don't want to make it so that he goes way up to the top when he's walking on the walls or anything. So I just basically set up a boundary where he moves his Y position at. So that's basically what that's doing. So let me go back here. Alright, so this stores his location. This is his Y location. Alright. Excuse me. This jumps back in the loop to keep the joystick updated. And this is the down position. Notice it's very similar to this, except as he reached 230, so is he way down on the bottom of the screen like I just showed you? If he has, then we want to keep him at that location so he doesn't end up flipping to the top again. You don't want him to flip backward and forward in a Y position. That's only usually natural in an X position because you're moving from room to room. You're not unless you're moving to room and you're way at the top and you want to move to a room up that way, then you obviously would flip this to something like 30 or wherever, the bottom part. Wherever you would want him to end up, basically. And this increment Y moves him up. This keeps a pause in the program so it's not running too fast. And up here, this is the down position for decrement Y. This stores it at his natural Y location once again. Okay, so it's basically it. Yep, vertical movement's pretty simple. Nothing compared to the X movement. X is just checking that most significant bit. That's the hardest part to understand, is understanding how that works. And that's basically all that is for this program. This is just a pause. We're just about done here. There's really nothing else I could show you. This is when I have more than one room, I'm checking the rooms and figuring out what I'm doing with each room. It says if we're near a wall here, then we're doing different stuff, but none of that's being programmed in. This is the bottom level. I'll show you where he walks on the floor. So this is all that I did to draw the bottom. I'm not going to go over all that, but basically I'm just drawing in positions here and filling in screen data. And this is high and low byte addressing to figure out where the screen's being drawn at. I'm not here to make a demo and showing you how to draw screens or anything. This is just for people wanting to know how to do the character sets and stuff, which I need to go over that too down here. So this is room 1. This is pretty long, so I'm go through this whole thing here. That's just drawing room 1. That's all it's doing. You'll be able to study the code once I have the file up on the website and people can download it. I'm sure I'll get a million questions then. Here's the clear memory I was showing you earlier. So these are the locations that's clearing the memory. I have to calculate them to even tell you what that is. I don't really know at this point. Just pulling up my calculator here. It's the same calculations I showed you earlier. You take the 64, you multiply it, or you add it to the 8. So looking blind here. Add it to the 8. Oops. You can see where my plus is. Plus 8 and times 256. I have like all my lights turned off, so it's like really hard to see anything. So 64, because it's really late, you know, I don't want to wake everybody up. So it's coming up to 18,432. I don't know what that means, but anyways, that's what it's basically doing, is addressing high and low bytes. So back to the character set. This is the character set data. This is what's necessary to initialize the character set that you're seeing on the screen, so that it's just not using the regular standard character set that comes with the Commodore 64 computer, basically the ROM character set. So when you want to initialize a character set, you also have to move it in the ROM. That's what this is basically doing down here. This is the movement routine right here. It's basically figuring out where the ROM location is stored, which this lookim is 253. So these are basically calculating it right here. If you can read high and low byte addressing, you would probably understand what these are doing. These are calculating and storing in the high and the low byte here into the ROM memory. 0 plus 32 times 256. I'm going to try to do that calculation here again real quick. 0 plus 32. 8192. So that's what I showed you earlier, where it was storing the 8192. So this is keeping track of exactly where this is going to store this at. And store it in the ROM. It's going to read in all the characters here. Get in the next most significant byte after you read the high byte, and it hits 255, it flips it back to 0, and it has to read the next byte in line. So that's how that kind of works. So, but that's basically all you need to initialize the character set. You just need to define these graphics here. This C set is picking up data. Oh, I'm sorry, this is picking, I'm sorry, that should be a load accumulator here. Right here, this is the load accumulator, look M. Plus picking up the high byte addressing. I think it's down here. I was trying to see where it's reading. It should be reading the characters in here somewhere. Let's see. 208. This is just moving the ROM. So somewhere down here, it's got to be where it reads in the individual characters. This is actually turning on the character set right here. Maybe it's down here somewhere. And what I'm saying is, let me kind of show you. I'm going to speed this up to show you what I'm talking about here. So I can go down to the bottom here real quick. Okay, so I'm going to turn this back on. So see the C set data? This is the character set data, basically. So it's, when you saw that C set 1, B1, and all that stuff, this is reading in all the each the redefined characters that you just saw earlier up in the program there. You want to set up byte statements when you're reading in data. That's how it works in assembly language. I know I already skipped over the part I wanted to show you down here so people can understand. This character 1 right here, this is the first sprite frame right here for the Pitfall Harry, and this is the second one. This is the third. These are the animation frames right here for the sprites. And these are just different flags I had set up for different things in the program. So if you want to use something like, you saw me use the flag for the most significant bit, you just set it to byte 0 and you can use it and change this as you move around and change the value in the accumulator. I'm going to have to jump this up because it's going to go through like 8 different rooms. They're pretty long. To draw them out, it's very long, so I'm just going to kind of skip ahead here a little bit. We'll go back to where we were, hopefully. We're around here somewhere, so I think I should be good right there. I'll try to cut this off. I also got some food on the stove here, so that's basically it for now, guys. I wanted to show you where that other character set was reading in, but I couldn't seem to find it here. Might have, actually, I did. I showed you it earlier. It was at the top. My bad. So when I go back here to the top, that's where it's I wonder I can hide it. It's at the very top here. That's where it's reading in all the character sets. I do that first in the program, and later we redefine the character set. So remember down here, this is redefining the character set. They have to redefine them here. As I showed you, not this one, this is the sprites right here. Down here, this is redefining the characters. So basically there's 8 per character. And each time we're done with 8 here, we go to the next one, and the next one, and the next one, and the next one, until we're all done with them. So it's basically, sorry I missed that point, but that's where it's all at. So I hope you enjoyed this video. I have to keep these short because I think Fraps has a time limit. Until I can figure out what's wrong with Camtasia, this is all I'm going to have to do for now, but maybe later we'll get into some more different kind of discussions once I start figuring out how to use these tools better. Thanks for watching, guys. Have a good day.